Hi there, welcome back to the channel and Happy New Year to everybody. This is the first video in the new year. So I hope 2025 brings you a lot of great stuff, a lot of toys, a lot of tools, and mostly health and time to enjoy them. I'm back with the Grundig 2447 restoration. This is the one that had quite a few surprises under the beautiful exterior. The beautiful exterior, by the way, is at the back there and it's practically done. It's something that didn't need much work and not much of a challenge, but I've done it and I'll show you the results at the end. The bigger challenge was actually to do with replacing that tuning condenser that someone had ripped out of there, and also finding out whether the radio sections worked at all. Spoiler alert, they do, but there were quite a few challenges along the way, especially with the AM. And with the AM, I had to find a replacement condenser. I managed to get the condenser to match the values of the original one with a little bit of tampering. Then there was another problem with the gearing. So this video is going to be focused primarily on that. And it was interesting, it was challenging, but ultimately I think the solution is there and I'm very near the end of completing this project. So if this sort of thing interests you, stick around and I hope you enjoy the video. Let me start out by correcting something stupid that I said last time. That was after something stupid that I did last time. If you saw the last video, you'll know that I had connected the speaker wires incorrectly. I had assumed that the black wire was ground and that the green wire was the signal, and this obviously affected the result because I had the signal generator providing the signal and it was creating a ground as well. If you haven't seen it, go back and see the video. It's really great to see someone being that dumb. But I actually made my stupidity worse by saying that someone had purposely misled me by swapping the wires, because to me ground is black, right? To a lot of people black is ground, right? Well, not in this case, and it was very clear if I'd looked at the schematic that that was not the case. You see, here's ground, chassis ground, and here it very clearly says groen, which is green or teal or blue, whatever that color was. It's faded by now. And schwarz is black, and that is most definitely not connected to the chassis ground. So it wasn't their trick or their mistake, it was my stupidity, and I admit it. And my resolution for 2025 is try and make fewer of those real newbie mistakes. And when I do, I'll just admit it and we'll all have a little bit of a laugh. Right, let me carry on with this project. But first I'd like to thank the sponsors of the video, PCBWay. You'll find them at PCBWay.com. They've supplied all the PCBs that I've used in my projects, as well as some 3D printing designs that I've developed. Most of these have been made available in the share section of the website, where you'll find thousands of community shared designs that you can order directly for your own builds. I've always found them to be fast, reliable, and exceptionally high quality, and the enormous range of services they offer will definitely assist you with every aspect of your design, including PCB assembly, if that's what you desire. Right now they're running the PCBWay Christmas Big Sales, where you save up to 50% and you can get free coupons, as well as many, many other goodies that you can take advantage of during this holiday season. So do yourself a favor, go to PCBWay.com. I'm sure you'll find something for your needs. All right, so we're back to the 2447, the Grundig 2447, and I have been messing around during the holidays trying to figure something out. I wanted to know whether the FM was working at least, because with the AM condenser removed, obviously that's not going to work, but the FM seems to have been untouched. And so I decided to set this up to test it. And what I did is I put in the tubes. They're all in there. That's the other thing. I wasn't sure, or I don't know that the tube's all working. I know that the power tube, the audio tube, is working because we've got audio. And after that stupid incident with reversing polarities, we've got good audio. So now I had to fit this one in. This is the EAF 801, ECH 81. That I've got a spare of, that I've got a spare of. And on the top here is the ECC 85, and I've got a few spares of that as well. So I needed to test that. And to do that, I wanted to restring it because there's no string. And this is always a task that I don't particularly like, but this one didn't work out too badly. I've got this restrung and it's pretty complicated because it goes on the underside there and then it goes under the tuning condenser. You see that little string over there? Goes through a pulley there, goes to the underside, comes across, and once it's across, it sort of gets into the gear mechanism over here. And this is a gear mechanism. So when you push FM, If you watch that spring over there, it pulls the gear one way, and when you push AM, it pushes the other way. So it'll either turn the spindle that's got the dial cord for the FM or the dial cord for the AM, which means that when you've got it on, say, FM, and you set it to a station, when you choose AM, it does not move. See that? Obviously, there's no pointer here yet, but if we're moving it, right? Now, if I have it on a station and I push AM, now it's trying to turn the AM tuning condenser, which is not in place, but the FM stays in the same location. With some radios, both would move, so if you flip over from FM to AM, you'd have to retune. This one is the gear version, so that's working pretty well. There's no setting here. This is just, I tightened it more or less. I put a spring in there. The other one was completely gone. And I'm not sure where this is going to be on the dial. I know that it's between, somewhere between here and there. And it does go across, but these things are obviously interfering with the hardware. I have to fix it in place later. But all I want to do right now is to check whether we've got FM. And if we've got FM, then I can carry on and sort out the tuning condenser issue, which is the one that's been on my mind these holidays. So let's get ready to test it and see what we're facing here. I have got the dim bulb limiter in place, and I've got 3 bulbs on there. And I'm going to press FM. The one dial lamp comes on, the other one is burnt, but we'll sort that out later. I've got the speaker in place, the workshop speaker, so I'm going to put the volume up high. Ha! Yeah. We've got audio. Whoa, we've got great audio. This is brilliant. I had tested it previously, but I hadn't had the antenna in place. I didn't realize just how good the sound was. This is damn good. I've only got music on this end, so I'll try and get to, I want to test the bass control. So let's get back to talk radio. So if I push, which one is it? This one? This is bass on, and this is speech, or bass off. Okay, so it's in reverse. More bass, less bass. Okay. Well, that was pretty simple. As I said, when I set this whole thing up, I had tested it, so I know a few things now. I know that the FM is working, the FM tube is working, the ECH81 is working, at least on the FM path. They do share a path, but this one also acts as an oscillator for the AM. I don't know if that's working. I've got that one there, the IF amplifier, I know is working. And of course, the audio is working. And this thing is sounding astounding. This thing is sounding really, really good. Well, that's encouraging. That is really encouraging. So what I'm going to do now, I'm not going to mess with the FM adjustment. I will do an IF, or rather I'll check the IF, but I'll do an RF alignment later, because I don't know whether the change of the dial chords, sometimes you get things messed up. You give it the wrong turn, or you turn once too many and it doesn't work well. But I've got this thing turning or tuning all the way across the dial, which means that I've got the dial chord basically right. And that wasn't magic. That's just a question of looking at the service manual, and they do give you the whole thing. So you really just have to follow the instructions carefully, and the FM one is the one below. And as you can see, it sort of goes over the top, and you have a little bit of a problem sometimes counting the number of turns that it does. And yeah, you don't get it first time. I didn't get it first time. You got to try a few times, which is why I normally just use tape to hold it in place temporarily, so I don't cut the cords in the wrong place and then have to redo the whole thing. This was just some old dial cord that I had here, and it's worked pretty well. In fact, there are 2 types. They used to use a metal line from this end to the tuning condenser. One side was metal, one side was cord. I've often used, or have used in the past, a high E guitar string, which works pretty well, but I just put dial chord. I wanted to get this thing up and running as quickly as possible, and I'm really pleased to know that the FM is working, and the sound is very, very good, at least on the speaker. So now we get to the AM, and that's where that's where it's going to get a bit more challenging. Let's see what we're possibly facing here. This is the section of the radio that we're interested in now. It's the AM block. We've got the AM front end, where the signal comes from the antenna over here, and it goes into the front end, and it's pre-selected, and then it goes into the mixer, and then on this side you've got the oscillator. So what they've removed is the tuning condenser, which in this case is this section and that section of the circuit. As you can see, there's one part of the tuning condenser that is in the front end, so it sort of pre-filters the station you're tuning to at the front end, and then the other section is on the oscillator, which creates the oscillator frequency, which is set to that frequency you're tuning to there, plus the IF frequency. Again, go to the Back to Basics videos, I've explained all that. So we've got two tuning sections, and there is one common line, and that is the ground. You see that? That one's connected to ground, that one's connected to ground, and so on these tuning condensers, we usually see that as one line. And then we've got that guy there and that guy there. So we are expecting 3 wires. And that's what we see hanging out at the top there, 3 wires. Now, I'm not sure where these wires go to. I'm not sure which is which. I can very quickly test the ground one, which should be low resistance or almost no resistance to the chassis. That will give me one of them. But then if I look at this one here, for example, where is it? This one here, if I test resistance from here to ground, I'm probably going to go through, I could actually, if this thing is set to that point, I could go through that. See those 2 coils there and that coil there? That'll give me a very low resistance to ground as well. So that'll be the front end coil. And this one, is there a path to ground? If I measure resistance from here to ground, and let's say I'm down here, where am I going to? No, that would be a high resistance. And up there, can't go there. Yeah, you see I could be shorted to ground, but that would be shorted to ground if I think it's the one where I am set to AM, to FM rather, because it stops the oscillator from working. So the easiest thing to do is to check where these lines are going to. This one's going to 11M and this one's going to 11E. They're bloody hell, they're close as well. That doesn't really help. But anyway, the point is we've got our 3 lines, which I'm hoping this is the only component they've ripped out of there. Because if it is, then I've just got to find a tuning condenser with 2 sections, and they're equal. Oh, they're not equal. Oh, hell. Yeah, usually or very often these are equal, and in this case it's not. The front end is from 9.5 picofarads to 502. So basically when the tuning condenser is completely open, it's 9.5 picofarads, okay? And when it's completely ganged, 502, call it 500 picofarads. There is obviously, for example, this guy here sets, you can pad it or you can adjust it when you do the RF alignment, but you're trying to get this as close as possible. So that one goes to 502 and that one goes to also from, let's call it 0 to 435. So they are slightly different, and that might be a bit of a challenge. But let's see what we've got. Let's see what we've got and see if we can sort something out, because we can use a different tuning condenser, which I've got to use obviously, but we can also use one with different values and try and pad it or reduce it depending on what value we're looking at. This is going to mess up the RF alignment on the dial or the dial accuracy, but that's the least of my worries right now. Let's see what I've got in the spare parts bin, Hoarder's Paradise, and that could work here. So we're looking for 435 and 502. Let's see how close we can get. Look what I found. All 3 of them in my parts bin. I've probably got a few more lying around, but these are what I think are the most promising to fit in the space that I've got up there. So I'm not sure which radios these are from. I'm not sure what the ratios of their capacitances are. You know, the back section to the front section. So what I need to do first is measure them, and that's going to be pretty simple. I've got my meter over here. I'm going to open it up, put it on. Let's try the back first. I'm doing the back element and then the front element. So what I've got here is, it's called a 13 picofarads. The back goes from 13 to, while we're there, let's do the front. 12, 2, and then let's mesh it completely. Front goes to 522, and the back goes to 529. So you see that's one that's the same. I'll do the same for the other two, and then we'll see what we're looking at. Okay, let's see if you can read my scribbles. The back section, front section. For this one, we get 13 to 529, 12 to 522. A bit higher than we need, and they are equal, which is, as I said, probably the more normal version. This one is 466 and 501. Now, if I remember correctly, we needed 505. Forget about the lower end. That is inevitable, unavoidable, because we don't... we can't really zero off you get stray capacitances going on there anyway. So 501 matches our 505, and 468 almost matches our 435, I think it was. That looks great. And this one goes to 570, 564. So again, that's sort of two equals. I think these two are going to go back in the parts bin. And now we've got our main contender, which is actually moving very well. I have to lubricate it a bit. And here are 3 connection points. That's the one end, that's the front end, that's the 466, so this will be the oscillator one. That's the no, this is the oscillator one, that's the front end one. The front end, as in the front end of the radio, 501, we needed 505, and that's our common ground. So this thing's looking really promising. Now it's just a question of figuring out how to connect it, how to fit it physically on there. I might have to 3D print some kind of holder. Yeah, this should be interesting. And also we'll need to figure out if the gearing is right. One can hope. That's the other thing I've noticed. This one has got gearing, and this one does not. See that? So this one would have been a little bit more complicated anyway. But yeah, I think we've got a contender. And this is actually strange because this has got fewer plates than that one, and it's got the higher capacitance at the front, which you would think, intuitively, you would think it would be the other way around. That is a bit odd. But anyway, actually, I've got an idea. I'm going to connect this up as it is, right over there, and see if we get lucky. I'll try and make sure I get the right one to the front end. I'm sure it's going to work. I'm sure it's going to work. Let me set it up and we'll try it. Right, I think I've got this right. I've got 3 crock leads on here. This white one I believe is the front end. I've checked where it goes on the switching. So the ground is the middle one. That I've checked. This one here, the yellow one, is for the oscillator. And they are connected to the 3 points over here. The ground, the oscillator one, this is the lower value at the back, and the higher value at the front. Now it's just a question of trying. Let's see, what is this? So this is FM, shortwave, medium wave. This is long wave. Let's try medium wave and see what happens. I've got the mini whoop connected. I'm being optimistic, but we have to be optimistic, don't we? I've got sound. Oh, that doesn't help too much. Let me insulate that. Just so that I don't affect it too much. Whoa!
En cualquier punto de España o del mundo, entra en nuestra página web.
This is the Canary Islands.
La pestaña de Mediodía en RTV.es.
That is perfect.
Canarias.
This is brilliant. I think this thing's working beautifully. Maybe not on that end. Let's see. Long wave, we don't get much at all. That is normal. Short wave, this is the 49 meter band. At this time of day, don't think so. I think this, no, this time of day, I wouldn't expect anything. But this thing's working. This thing is working. Bloody hell. What were the chances of finding, let me make sure everything is off. This thing is working beautifully as it is. Now, I know the RF alignment needs to be done, and I may still need to reduce this a bit. And the way to reduce it is actually quite simple. What you do is you put a fairly big capacitor in series with that. And because capacitors will reduce when you put them in series, rather than, you know, add when you put them in parallel, I want to reduce it. So let's say I put 100 nanofarad in there. This will come down a few picofarads. If I put a 10 nanofarad or 1 nanofarad, I can get this thing down to 435. I know I can. In fact, I'm going to show you what value it is. I'm going to do it by trial and error. I want to get that to 435. This thing is spot on 501, and I know that with the pattern we've got on there, we can get this to 505. That's not an issue. I want to drop that to 435 or 440. Let's see what capacitor we need in series to get that. Now, I decided to do things a little bit more scientifically. I've got this calculator or this app on my phone, and it's come in useful many, many times. So it's got one of these series capacitance calculators. You just put in the values and you can figure out what capacitor you need. And this is a screenshot of that test that I did. Now, what I did is I put in 466 as the fixed capacitor, and then I tested a few values in there. And the one I came up with was 6.8 nanofarads. That 6.8 nanofarads is in series with that gang of the capacitor. And now let's see where it takes us to. That is the least. So we've got our 12 picofarads, wouldn't make much difference there. And as we go up, get to the top, and we've got 437. We wanted 435. Hey, that's pretty good. That is exactly what I'm going to use. And the front one, of course, is 501 to 505. No difference really. I mean, if you look at some straight capacitances, you probably got double that just in this wiring. But I think we found our replacement. Now I've just got to figure out a way of putting this in there. Yeah, sometimes you get lucky. As I said, sometimes you get lucky and sometimes you don't. This is a little bit of both. You'll see that this capacitor is in place. It's sort of still loose, but it's got a rather strange spindle on here. If you recall in the beginning, I said they sent their spindle with them. This would have been the spindle that the original capacitor used. And I believe it because it's very similar. In fact, I think it's identical to the FM one. But I ran into a problem, and that problem has got to do with gearing. But one step at a time. Let me show you how I'm fixing this. This is temporary, but I'll be fixing it fairly much in the same way. Let me just go close up at the back and show you what I mean. This bracket that they've got here has got some holes, and I think it's missing some because this is rather odd. I went looking for photographs of this particular model, I wanted to see the inside to see how they'd fit or how the capacitor was fitted. And invariably, they are fitted horizontally across here. Also, the spacing between the screws is not as wide as this. In fact, I think it's probably from there to there, which means this would have a hole. Yeah, probably it would be those two. Let me show you. I've got a couple here, and you can see it's not that clear because nobody really focused on the tuning condenser, but you can see that they're horizontal, and they certainly are closer together than these two that I have here. And of course, the capacitor is flat. But I wanted to test this, and I wanted to test the range of the tuning, the span of the tuning on the front, on the dial. I'll explain that when I turn this around. So I just fit it in a way that it does fit with the holes that I have on this capacitor, which was one there, one there. It's angled. It makes no difference. It won't be left like this. But let me show you the front and show you the problem that I came across. The problem's got to do with gearing. It's actually got to do with the ratio of the turn to radius. In other words, or rather to the circumference of this particular gear. And it's actually fit like that. And I've got the drawing from the service manual. That's not an issue. This thing fits in the rod there, and then there's one screw there that you tighten it, and it shows you that it picks it up there, goes around, and it picks it up there, goes round. In either case, the two leave the bottom. That's the important thing. It's connected so that the two come out the bottom. None of them come out the top, and it's got to be that way because they've got to go past quite a few little things like that, and some of the components on the potentiometer on the right-hand side here. The problem that I found is when I had this in place and I turned, and it's turning now, as you can see, getting this from fully open to fully closed by turning the tuning, in other words, getting that to turn with the bigger wheel, this particular line here where the dial pointer would be was going off the scales. In other words, my gearing inside there is wrong. So the best way to do that, I mean, I could dismantle this and try and find a different gear, but that would be practically impossible. I mean, it would be easier to find an original replacement capacitor. The easiest way to do that is to change the diameter of this cog over here. In other words, of this thing over there. And rebuilding this or reprinting this is not easy, but this is the one that was actually on this particular capacitor. And it's different. It's got an adjustment screw over there, tightening screw. You can still do the same thing there, but instead of having these latches in the middle, it's got a cut across the top. And that's very clever because what you do is you use one string that starts here, goes around, crosses this cut on the pulley, whatever you want to call this, and then it goes the other way, and then it goes all the way that way, and it comes back and meets here. So it's one string. And I decided to redo this. I actually tried with this one, and this one was giving me, well, let me go back. I measured the span that I needed from one end to the other, and it was 20.5, I think it was. 21.5, 20.5. Let me check. Actually, it was 21.2 centimeters. And this thing was giving me like 14 centimeters with this guy. So I figured I needed to design one that was between this diameter and that diameter. That was too much. That was probably giving me 40 centimeters, which I don't have here. And this one is giving me too little. So I needed to design one in between. And I did that. I designed that guy there. Here's the first version. Just did it on Fusion and 3D printed it. And you know what? Other than the fact that that groove in there was not deep enough and the wires were sort of winding on each other, and also the fact that I needed about another 0.2 millimeters on here, and I hadn't put a hole in there to tighten it, the diameter that I chose right at the beginning was perfect. It was perfect. I put a bit of tape on the dial cord over here, right against this edge. And I have the capacitor fully open. Now if I start closing the capacitor by turning the tuning dial, you can see that moving across. And we get to the point where the capacitor is now fully open. So I've tuned across the entire span of the capacitor, and if I put this over here, I get 21.2, 21.3. Damn, that's close. What did I say? 21.2. That is amazing. That is perfect. And I don't know how I did that. I wasn't going to do calculations. You can do calculations, but I did electronic engineering at varsity, not mechanical. So calculating pulleys and the diameters of pulleys and that sort of thing is not my game, but I just got lucky. So yeah, now we've got this thing working perfectly. It's going across just fine. And there are a few more challenges to face. But at least I'm happy to report that the cabinet is not one of them. This was actually very simple to do. Because all the edges, all the sides are plain or flat, it was a matter of just sanding it lightly, getting it down a little bit through some of the lacquer. There was very little lacquer on here. The top surface was sanded a little bit more thoroughly, and then I just sprayed lacquer on, and at the end I used some of that furniture restorer, Pronto furniture restorer, which you see on the left there. Just a layer of that. It's like an oil, and it's come out beautifully. I'll let it dry, and if I think it needs something else, I'll give it a little bit more attention. But other than that, I think the cabinet is perfect. Now, what do I need to do? Well, there are a few things still to be done on here. I'm going to have to decide exactly how I'm going to fix that condenser, the tuning condenser on there. It's going to be fitted flat. I'm going to have to probably drill a hole in the back of the condenser to meet those holes at the back. I've got to make sure that this thing rests properly on here. So I may have to wedge something in here or 3D print something that'll hold this in place. I then have to sort out the tightening or the tensioning of the dial cords with the springs, make sure that everything is fine. I've actually got the FM dial, but I don't have the AM dial, so I'll have to 3D print something there as well. That should not be difficult. And then it's a question of aligning it. And on the subject of aligning, I'll have to do the realigning of the RF, especially, well, specifically for the AM bands, because I tested this last night and this is what I found. I found that the long wave was beautiful. The medium wave was fantastic as well. Short wave is a little deaf, and that could have to do with the front end alignment, RF alignment of the front end section of the shortwave band, which is perfectly normal. I did not expect this thing to work straight off the bat. I expected some issues, and the fact that I'm only having an issue with the shortwave is very, very promising. So that's where I'm going to leave you now, because this holiday season sort of got me into a lazy mode, and I hope you'll forgive me for that. So yeah, back to the normal mode, and I want to get this thing finished as soon as possible, because I want to get this thing added to the collection of the other two. So once again, I hope you've enjoyed that, and if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Links are in the description below. Thanks for watching. Bye for now, and most of all, stay safe.